Top 30 GraphQL Interview Questions and Answers. GraphQL is a powerful query language for APIs, enabling clients to request exactly the data they need and nothing more. It has become increasingly popular due to its efficiency, flexibility, and developer-friendly approach. Whether you are a developer, engineer, or architect, preparing for a GraphQL interview requires knowledge of core concepts, schemas, queries, mutations, and subscriptions. This guide covers the top 30 GraphQL interview questions and answers, helping you build confidence and perform successfully. 1. What is GraphQL? GraphQL is an open-source query language developed by Facebook in 2012 and released publicly in 2015. It provides a more efficient, flexible, and powerful alternative to REST APIs. With GraphQL, clients can specify exactly what data they need, reducing overfetching or underfetching of information. It supports queries, mutations, and subscriptions, making it highly adaptable for modern applications. Its strong type system, introspection capabilities, and real-time support make it a preferred choice for developers building scalable APIs. 2. How does GraphQL differ from REST? GraphQL differs from REST in its ability to allow clients to request only the data they need, rather than relying on fixed endpoints. REST often requires multiple round trips for related data, while GraphQL retrieves all necessary data in a single query. REST endpoints are rigid, while GraphQL is flexible with its schema. GraphQL also reduces overfetching and underfetching, supports real-time updates with subscriptions, and offers strong type validation through schemas, making it highly efficient. 3. What are the main components of GraphQL? GraphQL consists of three main components: schema, queries, and resolvers. The schema defines the structure of the API, including types, fields, and relationships. Queries are used to fetch data, while mutations are used to modify data. Resolvers are functions that resolve queries or mutations by connecting them to actual data sources. Additionally, GraphQL supports subscriptions for real-time data and introspection for self-documentation. Together, these components form a flexible, efficient, and powerful API architecture. 4. What is a GraphQL schema? A GraphQL schema defines the types, queries, mutations, and subscriptions available in an API. It acts as a contract between client and server, ensuring clarity and predictability. The schema specifies objects, fields, and their relationships, along with input and output types. Developers use schemas to validate queries and enforce strong typing. Since GraphQL is schema-driven, the schema is essential for enabling introspection, documentation, and consistent communication between clients and servers, making APIs reliable and easier to manage. 5. What is a resolver in GraphQL? A resolver in GraphQL is a function responsible for fetching the data for a specific field in the schema. When a query is executed, each field maps to a resolver, which retrieves the requested information from a data source such as a database, API, or service. Resolvers enable flexibility by allowing data aggregation from multiple sources. They ensure that GraphQL queries are translated into actionable instructions, bridging the gap between schema definitions and actual business logic. 6. What are GraphQL queries? GraphQL queries are used to fetch data from a GraphQL API. Unlike REST, where multiple endpoints may be needed, GraphQL allows a single query to retrieve structured and nested data. Queries follow the schema definition and return JSON responses that mirror the query shape. This prevents overfetching and underfetching of data. Clients can specify exactly what fields they need, including relationships. Queries are strongly typed, ensuring validation against the schema, making data fetching more efficient and predictable. 7. What are GraphQL mutations? GraphQL mutations are operations used to modify data, such as creating, updating, or deleting records. They are similar to post, put, patch, and delete methods in REST. Each mutation is defined in the schema, and clients can request specific fields to be returned after execution. This allows users to immediately retrieve updated or related information without additional queries. Mutations follow the same syntax as queries but include the mutation keyword. They ensure efficient, controlled modifications in APIs. 8. What are GraphQL subscriptions? GraphQL subscriptions enable real-time communication between clients and servers. Using WebSockets, subscriptions keep clients updated when specific events occur, such as new messages in a chat or stock price changes. Defined in the schema, subscriptions allow clients to listen for changes and receive data automatically without requerying. They are ideal for applications requiring live updates, ensuring interactive and dynamic user experiences. Subscriptions enhance GraphQL by supporting queries, mutations, and continuous real-time data streaming simultaneously. 9. What is introspection in GraphQL? Introspection in GraphQL is a feature that allows clients to query the schema itself. With introspection queries, developers can explore available types, fields, queries, mutations, and subscriptions. This self-documenting capability makes GraphQL APIs easier to understand and use. Tools like GraphQL and Apollo Studio rely on introspection for generating documentation and schema exploration. Introspection enhances developer productivity by eliminating the need for separate API documentation, ensuring schemas remain transparent, discoverable, and consistent throughout development and maintenance. 10. What are the advantages of using GraphQL? GraphQL offers several advantages, including efficient data fetching by allowing clients to request only required fields. It reduces overfetching and underfetching, common in REST APIs. Its strong type system ensures reliability and validation. GraphQL supports real-time updates via subscriptions and offers self-documentation with introspection. Developers benefit from flexibility, scalability, and faster development cycles. Additionally, GraphQL enables aggregation of data from multiple sources, making it suitable for microservices and complex APIs, thereby enhancing user and developer experiences. 11. What are the disadvantages of GraphQL? Despite its benefits, GraphQL has challenges. It can be complex to implement, especially for beginners. Overfetching by poorly designed queries may cause performance issues. Rate limiting and caching are harder to manage compared to REST. GraphQL APIs may expose too much data if not properly secured, increasing security risks. Large queries can put a heavy load on servers. Additionally, subscriptions add infrastructure complexity. Therefore, GraphQL requires thoughtful planning, monitoring, and optimization to maximize effectiveness while minimizing drawbacks. 12. What is the GraphQL type system? The GraphQL type system defines how data is structured and communicated between client and server. It includes scalar types like int, string, boolean, float, and ID, as well as object types, enums, interfaces, unions, and input types. These types ensure queries are validated before execution. The schema uses the type system to enforce rules and return predictable results. This strong typing improves clarity, prevents errors, and provides consistent communication, making GraphQL APIs more reliable and easier to maintain. 13. What are scalar types in GraphQL? Scalar types represent the most basic units of data in GraphQL. Built-in scalar types include int, float, string, boolean, and ID. Each scalar defines a single value and cannot be broken into subfields. For example, string holds text, while ID represents unique identifiers. Developers can also create custom scalars for formats like dates or emails. Scalars are essential for defining fields in object types, ensuring consistent data representation and validation across the GraphQL schema. 14. What are custom scalars in GraphQL? Custom scalars extend GraphQL's built-in scalar types to handle specialized data formats like datetime, email, or URL. They allow developers to enforce validation rules and data constraints. For example, a datetime scalar ensures only valid date values are accepted. Implementing custom scalars requires writing serialization and deserialization logic in resolvers. This improves schema expressiveness, enabling APIs to better reflect domain-specific requirements. Custom scalars enhance flexibility and ensure precise handling of specialized data within GraphQL applications. 15. What are enums in GraphQL? Enums in GraphQL represent a fixed set of possible values for a field. They are useful for restricting input to predefined options. For instance, an enum status might include values like active, inactive, or pending. Enums improve schema clarity, ensure data consistency, and provide better documentation. They also enhance validation by preventing invalid inputs. By using enums, developers make APIs more expressive, predictable, and easier to use, while maintaining strict control over acceptable values for specific fields. 16. What are GraphQL interfaces? Interfaces in GraphQL define a set of common fields that multiple object types can implement. They allow for polymorphism by enabling queries to return objects that share common structures while differing in other fields. For example, an interface character could be implemented by human and droid types. Interfaces improve reusability, consistency, and abstraction in schemas. They are valuable in complex domains where multiple object types need to follow a shared contract, ensuring flexible yet structured APIs. 17. What are GraphQL unions? Unions in GraphQL allow a field to return one of multiple object types without requiring shared fields like interfaces. For example, a search result union may return either a user, product, or order. Unlike interfaces, unions don't enforce common fields, offering greater flexibility. They are useful in scenarios where different types of results must be handled dynamically. Unions enhance GraphQL schemas by supporting complex query patterns and enabling clients to manage heterogeneous responses effectively in applications. 18. What are input types in GraphQL? Input types in GraphQL define the structure of arguments passed to queries and mutations. They allow grouping of related parameters into a single object, making APIs cleaner and easier to use. For example, an input type user input might include name, email, and password. Input types cannot contain fields that return functions or unions, but they can include scalars, enums, and nested input objects. They simplify argument handling, improve schema readability, and reduce complexity in query design. 19. What is a GraphQL fragment? A fragment in GraphQL is a reusable unit of a query that defines a set of fields. Fragments allow developers to avoid repetition by grouping commonly used fields and reusing them across multiple queries or mutations. For example, a fragment user details might include ID, name, and email, and be applied in multiple queries. Fragments improve maintainability, readability, and consistency in queries, making it easier to manage large or complex GraphQL requests across applications. 20. What is the N+1 problem in GraphQL? The N+1 problem in GraphQL occurs when querying nested data causes multiple database calls. For example, fetching a list of users and their posts might result in one query for users and n additional queries for posts. This impacts performance significantly. To resolve it, developers use techniques like data loader, which batches and caches requests to reduce redundant queries. Properly handling the N+1 problem ensures GraphQL APIs remain efficient, scalable, and optimized for high-performance data fetching. 21. How do you handle authentication in GraphQL? Authentication in GraphQL is usually handled at the resolver level. Clients pass tokens, typically in HTTP headers, which are validated by middleware or resolvers. JSON Web Tokens, JWT, are common for stateless authentication. Once authenticated, user context is passed to resolvers, enabling role-based access control. Developers can secure specific queries, mutations, or fields based on permissions. Proper authentication ensures that sensitive data is protected, preventing unauthorized access and maintaining security in GraphQL applications. 22. How do you handle authorization in GraphQL? Authorization in GraphQL determines what authenticated users can access. It is implemented using middleware, resolver-level checks, or schema directives. For example, role-based access control, RBAC, can restrict certain queries or fields to specific roles. Context objects often store user roles and permissions, which are validated during query execution. Fine-grained authorization ensures that sensitive operations and data remain protected. By combining authentication and authorization, GraphQL APIs maintain robust security while providing tailored access to users. 23. How does GraphQL handle versioning? Unlike REST, GraphQL avoids traditional versioning through its flexible schema design. Instead of creating new endpoints like /v1 or /v2, GraphQL allows adding new fields and types while deprecating outdated ones. The @deprecated directive helps indicate unused fields, guiding clients toward alternatives. This approach maintains backward compatibility while enabling continuous evolution. By avoiding endpoint proliferation, GraphQL provides seamless updates and reduces client migration challenges, making version management more efficient and developer-friendly in API development. 24. What is GraphQL? GraphQL is an in-browser IDE for exploring and testing GraphQL APIs. It provides features like syntax highlighting, auto-completion, error reporting, and schema documentation. Developers can write queries, mutations, and subscriptions interactively, making debugging and learning easier. GraphQL leverages GraphQL introspection to provide real-time schema information. It improves developer experience by streamlining testing and exploration, allowing quick feedback and iteration. GraphQL is widely used during GraphQL development, ensuring smooth collaboration, faster debugging, and easier onboarding for new developers. 25. What is Apollo Client in GraphQL? Apollo Client is a popular JavaScript library used for managing GraphQL queries, caching, and state management on the client side. It simplifies data fetching by handling queries, mutations, and subscriptions efficiently. Apollo provides caching mechanisms, optimistic UI updates, and error handling, enhancing user experience. It integrates seamlessly with frameworks like React, Angular, and Vue. Apollo also offers developer tools for debugging and schema exploration. With Apollo Client, developers build faster, more reliable, and responsive GraphQL-powered applications. 26. What is Apollo Server in GraphQL? Apollo Server is a widely used open-source library for building GraphQL servers in Node.js. It integrates with frameworks like Express, Koa, and Happy, providing a simple way to define schemas and resolvers. Apollo Server supports subscriptions, federation, and schema stitching. It also offers performance monitoring, error tracking, and schema analytics. By providing an efficient and extensible platform, Apollo Server allows developers to build scalable, production-ready GraphQL APIs with minimal effort, enhancing both development and operational workflows. 27. What is GraphQL Federation? GraphQL Federation is a technique for creating a single unified GraphQL API from multiple services. It allows teams to own separate subgraphs that represent distinct domains and then combine them into one federated schema. Apollo Federation is the most widely used implementation. Federation enables microservices architectures, ensuring modularity and scalability. It allows organizations to scale teams independently while still providing a seamless API to clients. This makes Federation ideal for large, distributed systems requiring collaboration and flexibility. 28. What is schema stitching in GraphQL? Schema stitching is a method of combining multiple GraphQL schemas into a single API. It merges schemas from different services, enabling clients to query them as one unified graph. Unlike federation, stitching often requires more manual configuration. It is useful when integrating legacy systems or external APIs. Schema stitching simplifies client interaction by hiding the complexity of multiple services. However, with the introduction of federation, stitching is less common but still valuable for specific integration scenarios. 29. How do you handle caching in GraphQL? Caching in GraphQL can be challenging because queries are highly flexible. Client-side caching libraries like Apollo Client or Relay cache query results based on query structure and variables. Server-side caching may involve response caching, resolver-level caching, or integrating with CDNs. Persisted queries also help reduce redundant requests. Caching strategies depend on the application's needs, but combining client and server approaches ensures improved performance, reduced load, and efficient resource usage in GraphQL-based applications. 30. How do you handle error handling in GraphQL? Error handling in GraphQL is done at both query and resolver levels. GraphQL responses include an errors field alongside data to indicate issues. Resolvers can throw custom errors for invalid inputs or failed operations. Middleware can handle authentication and authorization errors consistently. Developers can use error codes, extensions, and logging to provide meaningful feedback. By separating data and errors, GraphQL ensures partial responses are possible, improving resilience and maintaining smooth client experiences even during failures.